So it's now the floor is for Mohammad.
Hello, my presentation is about dual drip subsurface drip irrigation system. Can it act as a hydraulic barrier? This is held by me and Professors Alazba and Professor Šimůnek. This is a recent photo for him. Both of us from King Salman University. Our problem, we know that a typical root system, the roots the density of roots are higher in the top quarter of the roots, and it is less when you go down. In light textured soil, it is reported that a variable amount of water going down and percolated in the lower layers of roots, which wastes a lot of water, especially in sandy soil and highly light textured soil. Several solutions for that. The first was to place a physical barrier, which is made of plastic, nylon, or even metal, like from Welsh et al. 1995. They said that it really barricades water, unlike the normal distribution. The problem here are that we have to trench, to dig a wide trench and to place the barriers that, like we did here in Sinai. This is costly and laborious. Even if we perform it by machinery, it is really tedious. In addition, that it is recorded that it causes some root rot and the root dwarfness, or what's so-called shallow root problem. In 2006, it was my PhD. We thought to place another dripper, two drippers, one or 2 emitters, one above each other. We thought that this will enhance the water distribution, and it did really. But this trench is very narrow, just 16 millimeters, and it can be placed by machinery like the primary dripper. We can adjust a machine to put the 2 emitters inside below each other. We made some field experiments, and for Jerusalem artichokes, it gave a very higher yield when the what's so-called hydraulic barrier exists, for about 48% more marketable yield. But the normal yield, the total yield, was about 12% increase only. In Saudi Arabia, we repeated it for tomatoes, and it gives about 43% more yield after the second season. The first season was almost similar. When we repeated it, it gives almost 43%, and for potatoes, about 47%. I don't know what is the 40s, no 60s, no 30s. Our objective is to simulate water flow and soil transport for an SDI system considering both the physical barrier and the dual drip system using the Hydrus package, and to evaluate whether or not the dual system can act as a hydraulic barrier for movement of water and sewage. We, in our material, we placed a single lateral and a single lateral with physical barrier, and we placed two emitters, the dual lateral system. The flux for the single laterals was 10 centimeters per minute, which is equivalent to 4 liters, 3.7 liters per hour, and the flux time is 60 minutes daily, 60 minutes every 2 days. The flux is 60 minutes every 2 days, here and here. While in the dual lateral system, we split the water between the two laterals to let the water remains the same between the three emitters. The application of water here, we applied it two times, one continuously. They work together, and other time the lower emitter works starts 30 minutes before the first the upper emitter starts. We call this sequential drip. We prepared our domain geometry 100 centimeters width, 130 centimeters deep, and the dripper or the emitter is 15 centimeters deep. The other, if exists, 10 centimeters below the first, and the physical barrier is 25 centimeters deep and 25 centimeter width. Initial conditions, the domain was uniform condition, and the boundary conditions, we selected no flux in the borders and free drainage below atmospheric in the upper here variable boundary condition, variable flux 1 and variable flux 2. Finally, this is no flux because it is impermeable. And this is the finite element mesh generated here. The results. We choose it to, this is the Hydrus output, and this is the timer panel. Here is single lateral, single plus physical, dual, simultaneous and dual sequential drippers. Here, this is after 1 minute, and see here, it's not yet started, it will start after 30 minutes. This is 5 minutes, 10, 20, 30, 60, 90, 6 hours, 12 hours, 24 hours, and 48 hours. We noticed that the only one which retain water or conserve water in the root zone is the physical barrier, and no noticeable differences between the dual lateral and the single lateral in this way. This is for loamy texture, and for sand, the operation here, 30, 60, 90, you notice that it is longer because of the texture, fine texture. 6 hours, 12, 24 hours, and 48 hours. The dual lateral is a little bit taller and wider, but still we cannot understand why these results of the crop, is this for that much of water or what? Still the physical barrier is the winner. Here we tried to add the crop effect. All of these were for bare soil, and this with crop. We put tomato. Here the crop effect is noticeable, but still we cannot interpret why this is better than this. This for loamy soil without crop and with crop. After contacting Jerka, we decided to study the solute transport. We studied the effect of the dual drip on solute distribution in the root zone. So we added two scenarios. The first scenario we studied before, 10 centimeters per minute for 60 minutes, and this 30 minutes, the lower starts before the first. And here we want to see the effect of pulsing. Here we started the first, the upper emitter first. Then after 120 minutes, we started the lower emitter, and the thing is reversed in the CD simulation scenario. This is for 2 days. This cycle repeated as a variable boundary conditions for 15 times, so we will show the simulations for 30 days. The upper is the water transport, and the water and the simulations down lower are the solutes. 6 hours the time down after 12 hours. See here, notice this 24 hours, 2 days, 10 days, 20 days, 30 days. Here we notice a difference between the CU and the CD and C. There is noticeable difference in the solutes, but no noticeable difference in water distribution. We can understand this because solutes are exerted from the upper dripper, and the lower dripper, the upper dripper starts pushing solutes and water, and then the lower get out water and pushes the solute, forcing it to redistribute in the upper zone. So it is very useful for fertilizers and whatever, and it pushes it laterally, unlike this. This we starts the lower, then the upper. So if we notice at this line here, the solutes and fertilizers, if it is fertilizers, are retained in the top region, while it is not here, less. So we can use this to, by altering the direction of which will operate first, we can control the solute leaching, and if we want to keep it or to leach it. Our conclusions: the application of dual drip system or the installation of a physical barrier can significantly alter both the wetting pattern and the spatial distribution of applied solutes. Physical barriers prevent downward movement of water, nutrients, and chemicals. Thus, their usefulness depends on the need of keeping or flushing these substances. A dual drip system can manipulate the distribution of solutes in the root zone, especially for sequential operations. Such a system allows growers to control solutes retaining or leaching by simply altering the operation sequence.
Thank you.
Thank you for this very flashy presentation. Are there any, and interesting also, of course. Are there any questions?
Yes. I'm not sure if I missed it, but what kind of soil did you use in your simulation?
Two soils, loam and sand.
No, the solute. Not
Sol-
the soil. The solute.
Solute?
Yeah.
I don't know what
Just
solute.
tracer.
Sorry?
Just tracer.
Tracer.
Conservative tracer, like bromide.
Yeah, tracer.
How you did the long-term simulation for season or 2 seasons to know how the behavior of the solute accumulation, because the 30 days is not like enough to,
We will
to do this.
We will do it.
To
We
conclude
did
from
only
it.
for 30 days. We will do long term. This is our next plan.
And I would like to see the root water uptake besides, for example, the root water uptake and the distribution of the root water uptake besides the distribution of the solutes, and then could be more
It
clear.
is in the paper, not shown here, but
Then
in the
it would
paper.
be interesting. Yes.
Yes.
This method with the barrier blocking the barrier,
Yes.
but the methods of flushing salts is common. Like you have to at some point flush salts from the wood zone. After I don't know a couple of seasons, you have too much of salts accumulates in this wood zone.
Yes.
And if you have this permanent barrier, what do you do?
Yes. This is the one of the drawbacks of it.
It's a problem.
This is
like-
yes. We want to remove this. We want to. We dislike the physical barrier. So no, that's why we put the what we call hydraulic barrier. But Dr. Yerka dislike this name. So it is dual lateral till now.
Okay, thank you very much again. And the floor is now for Tiago.